Hello and welcome to my video series on functional J. Today, let's discuss choice type. First off, functional J is a library for writing functional style code in Java. Functional J brings many functional goodies to Java. You can go to functionalj.io to learn more about its features, see some example, or you can go to its GitHub page to get the code and learn more about that there. This video is a companion video to a blog post I published on DZone. You can get all the link in the description as well if in case you prefer reading. So come back to choice type. What is choice type? In essence, a type in the programming language, among other things, specify what are possible values that can be assigned to a variable of that type. For example, Boolean variable, you can assign true or false in it. Or byte, you can assign a whole number from -28 to +127. This is in case for Java. But those types are specified based on a very large vague possible number from a big range of number or something like that. But choice type will allow you to specify exactly what value are valid to be assigned to a variable of that type. Think of it as an enum. But choice types also allow you to parameterize its value by having payloads. Choice types been around for very long as part of functional programming languages. It's known sometimes as some types or type. Discriminated union type or tag union. As I said, the choice type has been around for a very long time. It's used for many places. So how do you use choice type in using functionalj.io? So in this case, we will use a notation called choice. So let's try to write one, a simple one. Similar to struct, if you haven't watched struct, see the video in the description. Struct is a way to create immutable data object using functional J. We do that by create an interface with the name and with spec, because we're going to because functional J will generate a class called up or down. So it's mandatory to have the word spec or model as a suffix for this. So in this case, we have two choices, up or down. This interface is called specification interface. Once we create that, we have two choices, up and down. We just write it as the method of this interface. Then we can annotate it with choice. At this point, functional J will generate a class called up and down that you can use. So let's say up or down, up and down. So let's say the first one is up. Then you can access to it as up, also as down, like that. Then you can have it print out either the up or the down. Okay, so as you see, it's true string. We just say up or down. So this point, it look exactly like enum. But as I said, the choice type is somewhat look like enum, but it allows payload. So let's see the case where it has payload. Let's remove this. So I'll create a class, our interface called login status, because it's a specification interface. So I have to suffix its name with spec. And there are two status. The login, it should have been log in, but let's go with this. User name. So when it log in, it have username, and when it log out, it has no payload. After that, I annotate it with choice. Once save, functional J will generate a class called login status. Notice that the class is generated in the same package with this this class, where in the same package with this specification. So then you can use it. Login will be login status dot login. So let's say root is logging in, and another status is login status dot logout. Notice that when it has a payload, you need to use this method login as static method is the way to generate that instance of that method. Think of it as a constructor of login. But in case of no payload, you have both the logout method like that, or you can have the static object, static final fields for that logout. So let's see if we print it out what we get. Right, if you see here, it said that the first one is an object called login with the parameter or payload root, and another one is logout. This still looks similar to enum, but it has this root. You can change the name as well. So let's say now my name, so I'm logging in, so I get that. So first off, what is this? So a login status is a class that got generated, and it have a subtype called login. So a choice become a subtype, as well as this logout. Right, so you can create and assign to a login or a logout directly, if that prefer. And another thing is that it's toString, it automatically generated. So you can use that. Hash code and equal is also automatically generated. So you can have hash code, and this hash code will always be the same for if the value of it are the same. So if I said get hash code of another instance of login with the same name, then you should expect them to be equal. Same with logout. Logout hash code just add a line here a little bit to show this is hash code. So you can see that the object with the same value will produce the same hash code. The same thing go with equal. The object with the same value will also equal to each other, even though they are created different. Even though they are created separately, like that. Logout equal. Right. So what I'm trying to say here essentially is that this object login and logout of login status class automatically has toString hash code and equal automatically generated for you, and it worked properly. So you already seen how we can access to that. So let's see how can we get to its payload. So in this case, because only login has payload, right? So basically you can access to the username as a method here. And if you don't know if it log in or log out, there are a number of ways to check that. So first off, you can cast it to log in like this. Another word, login is a subclass of login status, and logout is also a subclass of login status. So you can click on this and open the generated code. You can see that we have an abstract class login, and this class has a private constructor so that only the class in these files can extend it, and no one else can extend this class. And there are two subclasses: login with extend login status, and logout with extend login status. So that's why you can do login is instead of login like that, as well as cast it down to login. So that's a way to do it. This type of class hierarchy is sometimes known as a seal type. So you create an abstract class, and then you have subclass, only known subclass that can extend from that abstract class. No one else can extend it. So it's sealed from further extension. So this mechanism is used to simulate choice type. So there are two possible choice type, login and logout. Next, if you don't like this instead of cast, there are a number of ways you can check if the object is what choice by using the is method. So you can ask if it's login or logout. Right? You can do it for both. Let's do it for both. So you can see that login is a login, and login is not a logout. Logout is not a login, and logout is a logout. So that's how you check whether what choice if that object really is. And then what if you want to access to that object as a choice? That's another way to do it without having to do the cast, and that is by using an as method. So you can access login as a login, and it's return a result object. A result object, you think of it as an optional object. So an optional object in Java 8 is a wrapper of an object. If the object is not there or is null, basically, then it will be empty option. This is similar. This is result, but result extends to some other things. So that's why we prefer to use the logout. The good thing about this is that you can map or basically make use of the thing inside of that. And this map function can only be run if it actually a login. It will be ignored if it's not a login, as you can see. So let's say if I get a map, and we know that inside of it will be a login object, right? And a login object I can map to its user like that. And after mapping that, I can further map it to let's say get its length. So we can get it length so in this case I'll extract So in this case, I said, whatever this object is, I'll get it as a login, and then I will map it. If it is a login, I'll map it to its username. Then I will get the length of that username, and whatever it is, return it. And if it's not there, then I'll return -1. So we can do the same thing for that as well. So this is what's going to return because this object actually a login, so that's why it goes through this map and this map, and then that's why it returns the result. Oh, I didn't copy that. Okay, but in case of logout, because logout is not a login, so this one got skipped, this one got skipped, and then it returned the else value, which is -1. If you're already familiar with optional object, this is exactly the same thing. So you can use it as a choice if you want, and just ignore another choice. So that is another way of using the value of particular choice. That's one. There are two more ways. The next one is if. So if it's basically saying that if you want to only run a code if it's a particular type, so you can say it, if it's a login, then give me the login object, and I will print out its username. Like that. So what do you expect to show? So it will show only the first one, because the second one is a logout object. So this code will never get to run. Only this code get to run. So that's another way of using getting to the choice. The last way of using it is a preferred way of using it. It's called pattern matching. Pattern matching is what other functional programming language use to handle choice type, and it's done like this. Oh, I better label that. Pattern matching login.match. So you can match it into login. If it case is a login, then you say I want username. If it's a logout, I will just say guess. And then you can assign this to like that. Let's print it out. I will also show you what the case of logout is. So in the first case, it said just match this login to either if it log in, then return its username, otherwise return guess. We can do it for login, and then it print out as now here. When we do it for logout, because logout is not a login, so it used this value to return logout. Why do this is a preferred way? Why pattern matching is a preferred way? Basically because it's exhaustive. If you don't do this, let's put this in a string. So there's no type inference here. So if you don't do this, it basically will return something else that's not a string. Therefore, you cannot use that. It has to handle all the cases for this to work, right? So it will get compilation error if you don't go exhaustive. So this is good because if later on you come in and then you change to something else like invalid password or something like that, or timeout of the login status, then you will get compilation error to the code that did not handle that specific case. This is good for your code. You are more free to refactor, because when you refactor, you don't get a silence bug anywhere. So that's why pattern matching is the way to go. Because login status is generated as an object, so you may want to add additional functionality to login status. How would you go about doing that? To do that, let's say we want to, instead of having to do this pattern matching to get the username every time, you want to create a method in here. So let's say this method will return string. We have to make it default, and this method returns string, and let's say user name. No, it cannot be just username because it will collide with that. So get username, and then to signal that this method will be an instant method of this login status. Unfortunately for us, we have to use a class called self to signal that, because we cannot use just login status here, because login status is a generated class and it's not available at the time of the code generation. So we use self to signal to the generator that, okay, please replace this one with login status, and we will get its value by unwrapping it. And then we can use pattern match to do that. Oh, let's copy the code here. So then we can say, okay, please match this login status, no matter what it is, and then return the username. At this point, then we can use okay, so let me create this. Additional methods. Okay. Login dot get username. As you can see, it returned the username in case of login to be Nawa, and then in case of logout, it just say case. As I said, it's important to note that if you want to create an instance method, in this case, this one would be an instant method, you make it default, and then you signal it with self, like that. So it will pass the instance into it, and then you can make use of that instance. So what if you want to create static method? To create static method, you do this. Why is it not okay to access to login status in the parameter? It's okay to do it as a return parameter. I don't know why, but that is what what the compiler allows us to do. So you can do that, string of username. So you can say if this is equal to now, if the username is equal to now, or if it's equal to guess. Then I'll return logout. And otherwise, I'll return login of that username. So from here, we can create a login and logout status dot of root or no, which you will see for root you will get root, and for logout we get logout there. So that's how you create static method into your login status. As I said, choice type has been around in many shape and form in other functional languages. So it's been used to it's used for many things like basic data structure, states, return value, command events, variance, expression, or unit automation. So let's see some of those examples. So let's see data structure. So these are examples of data structure implemented using the choice type. So maybe it's like optional in many languages, exactly the same thing. So you have just a nothing. So it implement using choice type. Either is said this data will hold either one type for the left and one type for the right. It generally used to as a result of something. So it said, I'm going to turn you to a valid result or an error message, for example. Or you can, and some languages use try to signal specifically that either a success case or a problem case. Or data structure like linked list in many functional programming language, it's just a node. So you create a node. Either it's an empty node, nil, or it's a node that holds a value and point to other node. So then you can wrap this linked list to become a longer list that you want. Next case is state. And in case of state, we already have that example. Login status is state. So either login or logout. And you can have something like a game can be the game initiated, the game start, player 1 is supposed to play or player 2 turn, or the game end with someone win, or the game end with cancellation. So the game is just terminated. Nothing. Return value. So you see try the similar way. So you can say request result. When you make a request over the network, you may get a success with the result in the type of T, or you may get an error message, mean that the connection is successful to that side, but something's wrong. Either it cannot process, or your data is in the wrong, so you get an error. Or a third choice is the connection cannot be made at all. It's failed because maybe the network is down or the server is down or something like that. Command and event. So some operation or some object can only operate with a few cases. Either like in this case, maybe a robot. Say the robot move forward, robot move backward, turn the robot, or do something like this case, explode or something. An expression, so you can see that this is a Boolean expression, so it can be true or false. You can do an or between left and right. You can do an and between left and right. Then you can get its value like that. So from its value, if it's true, return true. If false, return false. If it or, just get the left and the right and or them out, and this one's wrong. And then for and, then you can just get and right and them together. And then You can also create toString with spell out how this expression is like here. So let's run this. So you can see that in case of toString, so just print it out as like that. It will say, okay, so it's true or false, or as and true or false, and then you get a true out of that, something like that. A variant, sometimes your operation or your method only accept a certain type of value, and these values may not have a specific type hierarchy that you can use to say I want this type, right? So in this case, Boolean, integer, string has nothing in common. They're all object. If you use object, then you get every other thing else. So you want to only say, okay, this operation I only accept Boolean, number, and string, or nothing. Like give me to specify that it's nothing. Like for example, JSON value can be only in this tree value, for example. So you can specify that this way using choice type. And the last example I have here is called the unit of measure. So in this example, I create an object called temperature, which can be either Celsius or Fahrenheit, and then it can be seen as a Fahrenheit. So you can say change whatever it is to Fahrenheit. So if it's Celsius, then you go through this calculation and you return the Fahrenheit object. And if it's already a Fahrenheit, then you just return this object. The same goes with Celsius. So when you run it, you will see the Celsius as Celsius, and the Celsius is Fahrenheit, and then Celsius as Fahrenheit and as Celsius go back to the same Celsius, for example. Or you can use it for something like an angle, can be a radius or degree, or if your system use US and Canadian dollar, you may also do that and find a way to put a rate in there. All right. So that is for choice type. What do you think? Do you have any situation where this is useful? You can find out about all this use case of choice type on the internet. Just search for tag union or discriminated union. It exists in many languages. So that is for today, and thank you for listening. I'll see you again in next video. Bye bye now.